And now what's the next scale, right? Like all the hyperscalers have done this. Now the next scale is something that's even bigger, right? And so, Elon, just to stick on the topic, he's building his own natural gas plant, like a proper one right next door. He's deploying tons of Tesla Megapack batteries to make the power more smooth and all sorts of other things. He's got like industrial chillers to cool the water down because he's water cooling the chips. So all these crazy things to get the clusters bigger and bigger. But when you look at, like, say, what OpenAI did with Stargate, that's that in Arizona, in Abilene, Texas, right? What they've announced, at least, right? It's not built, right? Elon says they don't have the money. There's some debates about this. But at full scale, at least the first section is like definitely money's accounted for, but there's multiple sections. But full scale, that data center is going to be 2.2 gigawatts, right? 2,200 megawatts of power in, and roughly like 1.8 gigawatts or 1,800 1,800 megawatts of power delivered to chips, right? Now, this is an absurd scale. 2.2 gigawatts is like more than most cities, right? To be clear, and delivered to a single cluster that's connected to do training, right? To train these models, to do both the pre-training, the post-training, all of this stuff, right?
This is insane.
It is. What is a nuclear power plant again?
Everyone is doing this, right? Everyone is doing this, right? Meta in Louisiana, right? They're building 2 natural gas plants, massive ones, and then they're building this massive data center. Amazon has like plans for this scale. Google has plans for this scale. XAI has plans for this scale, right? Like all of these, the guys that are racing, the companies that are racing hard, and they're doing multi-gigawatt data centers, right? To build this out because they think that if I now have obviously pre-training scaling is going to continue, but to some extent, but then also all this post-training stuff where you have a RL sandbox for computer use or whatever, right? Like, this is where they're going to, and all these viable domains where they just keep learning and learning and learning, self-play, whatever it is, makes the AI so much more capable because the line does go up, right? As you throw more compute, you get more performance. The shirt is about scaling laws. To some extent, it is diminishing returns, right? You 10x the compute, you don't get 10x better model, right? You get a diminishing returns, but also you get efficiency improvements, so you bend the curve, right? And these scale of data centers are doing, wreaking, a lot of like havoc on the network, right? And Nathan was mentioning there's Amazon has tried to buy this nuclear power plant, Talon, and if you look at Talon stock, it's just like skyrocketing, and they're building a massive multi-gigawatt data center there. And, you just go down the list. There's so many ramifications. Interesting thing is like certain regions of the US, transmitting power cost more than actually generating it, right? Because the grid is so slow to build and the demand for power and the ability to build power and like re-ramping on a natural gas plant or even a coal plant is like easy enough to do. But like transmitting the power is really hard. So in some parts of the US, like in Virginia, it costs more to transmit power than it costs to generate it, which is like, there's all sorts of like second order effects that are insane here.
Can the power grid support this kind of growth?
Trump's executive orders, there was a Biden executive order before the end of the year, but then Trump had some more executive orders, which hopefully reduce the regulations to where, yes, things can be built. But yeah, this is a big challenge, right? Is building enough power fast enough.
Are you going to basically have a nuclear power plant next to a data center for each one of these?
So the fun thing here is this is too slow.
To build the power plant.
To build a power plant or to reconfigure an existing power plant is too slow. And so therefore you must use data center power consumption is flat, right? It's spiky,
which is
right?
why nuclear is also good for it. Like long term, nuclear is a very natural fit, but you can't do solar or anything in the short term like that.
Because data center power is like this, right? Like you're telling me, I'm gonna buy tens of billions of dollars of GPUs and idle them because the power's not being generated. Like power is cheap, right? Like if you look at the cost of a cluster, less than 20% of it is power, right? Most of it is the capital cost and depreciation of the GPUs, right? And so it's like, well, screw it. I'll just build natural gas plants. This is what Meta's doing in Louisiana. This is what OpenAI is doing in Texas and like all these different places. They may not be doing it directly, but they are partnered with someone. And so there is a couple hopes, right? Like one is, and Elon, what he's doing in Memphis is like, to the extreme. They're not just using dual combined cycle gas, which is like super efficient. He's also just using single cycle and like mobile generators and stuff, which is less efficient. But he's, there's also like the flip side, which is like solar power generation is like this, and wind is another like this, different correlate, different. So if you stack both of those, plus you get a big chunk of batteries, plus you have a little bit of gas, it is possible to run it more green. It's just the timescales for that is slow. right? So people are trying, but Meta basically said, whatever, don't care about my sustainability pledge, or they'll buy like a power. It's called a PPA, power purchasing agreement, where there'll be a massive wind farm or solar farm, like wherever, and then they'll just pretend like those electrons are being consumed by the data center, but in reality, they're paying for the power here and selling it to the grid, and then they're buying power here.
Yep.
And then another thing is like Microsoft quit on some of their sustainability pledges, right? Elon, he what he did with Memphis is objectively somewhat dirty, but he's also doing it in an area where there's like a bigger natural gas plant right next door and like a sewer next, or not a sewer, but like a wastewater treatment and a garbage dump nearby, right? And he's obviously made the world a lot more clean than that one data center is going to do, right? So I think like it's fine to some extent, and maybe AGI solves global warming and stuff, right? Whatever it is, this is sort of the attitude that people at the labs have, right? Which is like, yeah, it's great, we'll just use gas, right? Because the race is that important, and if we lose, that's way worse. Right.
I should say that I got a chance to visit the Memphis data center.
Oh, wow.
And it's kind of incredible. I mean, I visited with Elon. Just the teams and the rate of innovation there is insane. Because my sense is that, nobody's ever done anything of this scale. And nobody has certainly ever done anything of this scale at the rate that XAI is doing. So they're like figuring out. I mean, and so I was sitting in on all these meetings where they're brainstorming. It's like, it's insane. It's exciting because they're trying to figure out what the bottlenecks are, how to remove the bottlenecks, how to make sure that, there's just so many really cool things about putting together a data center because, everything has to work. It's the people that do like the sysadmin, the machine learning, all that is the exciting thing, so on. But really, the people that run everything are the folks that know like the low level software and hardware that runs everything, the networking, all of that. And so you have to like make sure you have procedures that test everything. I think they're using Ethernet. I don't know how they're doing the networking, but
they're using NVIDIA Spectrum-X Ethernet. There's actually I think, the unsung heroes are the cooling and electrical systems, which are just like glossed over.
Yeah.
But I think like one story that maybe is like exemplifies how insane this stuff is when you're training, right? You're always doing you're running through the model a bunch, right? In the most simplistic terms, running through the model a bunch. And then you're going to exchange everything and synchronize the weights, right? So you'll do a step. This is like a step in model training, right? And every step your loss goes down, hopefully, and it doesn't always. But in the simplest terms, you'll be computing a lot and then you'll exchange, right? The interesting thing is GPU power is most of it. Networking power is some, but it's a lot less. But so while you're computing, your power for your GPUs is here. But then when you're exchanging weights, if you're not able to overlap communications and compute perfectly, there may be a time period where your GPUs are just idle and you're exchanging weights and you're like, hey, the model's updating. So you're exchanging the gradients, you do the model update, and then you start training again. So the power goes, right? And it's super spiky. Yeah. And so funnily enough, right, like this, when you talk about the scale of data center power, right, you can blow stuff up so easily. Yeah. And so Meta actually has accidentally upstreamed something to code in PyTorch where they added an operator. And I kid you not, whoever made this, like I want to hug the guy because it says PyTorch, it's like PyTorch.powerplant no blow up equals 0 or equal 1. And what it does is amazing, right? Yeah. Either, when you're exchanging the weights, the GPU will just compute fake numbers. So the power doesn't spike too much. And so then the power plants don't blow up because the transient spikes like screw stuff up.
Well, that makes sense. I mean, you have to do that kind of thing. You have to make sure they're not idle. Yeah.
And Elon's solution was like, let me throw a bunch of Tesla megapacks and a few other things, right? Like everyone has different solutions, but like Meta's at least was publicly and openly known, which is just like set this operator. And what this operator does is it just makes the GPUs compute nothing so that the power doesn't spike.
But that just tells you how much power you're working with. I mean, it's insane. It's insane.
People should just go to Google, like scale, like what does X watts do, and go through all the scales from 1 watt to a kilowatt to a megawatt, and you stare at that, and you're how high on the list a gigawatt is, and it's mind blowing.
Can you say something about the cooling? So I know Elon's using liquid cooling, I believe, in all cases. That's a new thing, right? Most of them don't use liquid cooling. Is there something interesting to say about the cooling?
Yeah. So air cooling has been the de facto standard. Throw a bunch of metal, heat pipes, etc., and fans, right? And like that's cooled. That's been enough to cool it. People have been dabbling in water cooling. Google's TPUs are water cooled, right? So they've been doing that for a few years. But with GPUs, no one's ever done, and no one's ever done the scale of water cooling that Elon just did, right? Now, next generation NVIDIA is for the like highest end GPU, it is mandatory water cooling. You have to water cool it. But Elon did it on this current generation, and that required a lot of stuff, right? If you look at like some of the satellite photos and stuff of the Memphis facility, there's all these external water chillers that are sitting. Basically, it looks like a semi truck pod thing. What's it called? The container. But really, those are water chillers, and he has like 90 of those water chillers just sitting outside. 90 different containers, right, with water, that chill the water, bring it back to the data center, and then you distribute it to all the chips, pull all the heat out, and then send it back, right? And this is both a way to cool the chips, but also an efficiency thing. All right, and going back to that like sort of 3-vector thing, right? There is memory bandwidth, flops, and interconnect. The closer the chips are together, the easier it is to do high-speed interconnects, right? And so this is also like a reason why you're going to go water cooling, is because you can just put the chips right next to each other and therefore get higher speed connectivity.